Hello guys, I hope you're holding up safe and healthy. So this blog post is in continuation with the last one in which we read about the basics of trigonometry, its ratios, some basic properties, etc. So in this one, we are moving ahead with some of the unique properties which all the trigonometric functions have and in the blog post, we already discussed about periodic, odd, even, then the signs of trigonometric functions, etc. So let's go ahead with some of the worked out examples so that will help you understand better. So first, let's talk about the periodic or let's say the odd even property. So these questions will be on this property. So let's talk about the first question. So the first one is we need to find the value of sine of 420 degrees. Now, in this video, I will be dealing mostly with degrees, but you should keep this in the back of your mind that uh, the degrees, whether it's degrees or whether it's radians, the formula behaves the same. So we need to find a value of sine of 420, but in order to find this, we first need to convert this basically in the first quadrant. So we know that 420 is nothing but 360 plus 60, and we know the property which we read that since the time period of sine is 360, so 360 k plus any angle theta is actually sine theta, where k is any integer, because the sine repeats itself after every 360 or a multiple of 360. So this value will just be sine 60 degrees, and sine 60 is nothing but square root 3 over 2. So this is the answer for this one. Let's talk about B. So this one has cos of 450 degrees. We need to find the value of this. So the method remains the same. We somehow have to have the first number either as 360 or a multiple of 360. So we can write this as 360 plus 90, and 360 plus 90 again as per the property of cosine, because the time period of cosine is again uh, 360. So over here we'll have cos of 360 plus 90 is cos 90 once again, and cos 90 is nothing but 0. So over here we have 0. Let's move to the next one. So this one says that we need to find a value of tan of 330 degrees. So tan of 330, the only difference is the time period of tangent and cotangent, or let's say tan and cot, is 180 degrees. So this can be written as, I want to write this as 360 minus 30. So let's try to rewrite it in terms of the form which we read. So this is actually 380 is nothing but 180 times 2, and negative 30 can be written as plus of minus 30. So if we recall the formula says that tan of 180k plus theta, this is actually equal to tan theta. So this is 180k plus theta format. So this will be equal to tan theta, where theta is negative 30. And now we use the odd even property. We know that tan is an odd function. So negative comes outside. Tan of negative 30 is nothing but negative tan 30, and tan 30 is nothing but 1 over root 3. So negative 1 over root 3 will be the final answer in this case. Let's move ahead with the other examples. So this one is sec of 405 degrees. So again, I will try to write this as 360 plus 45. Period of sec is again 360, so this will be sec of 45, and sec 45 is nothing but square root of 2. Next one is cot of 405 degrees. Again, procedure remains the same, but the only difference is the time period of tan or cot is 180. So if we write this as 360 plus 45, we need to remember that this 360 is actually 180 times 2, because that is the format of the formula. And tan of 180k plus theta is nothing but tan, or whether it's cot. So it is cot of theta, which is cot of 45, and cot 45 is nothing but 1. Let's move ahead with the other examples. So these all examples are actually a kind of a practice which you have to do in order to get a good grasp on this various angles. So let's say we have cosec 390. Cosec 390 is nothing but cosec 360 plus 30, and again the time period of cosec is 360, so this will be cosec 30, and cosec 30 is nothing but 2. Let's talk about the other one. So we have cos of negative 780. Now we need to remember the odd even property. We know that cosine is an even function, so cos of negative 780 is nothing but cos of 780, and 780 can be written as cos of 720 plus 60, and 720 is nothing but 2 times 360 plus 60. So again, using the property, we know that the time period is 360, so this is nothing but cos of 60, and cos 60 is nothing but 1 over 2. Let's talk about the next one. So the earlier one was G, so we move to H. This one is sine of negative 1125 degrees. So first of all, sine is an odd function, so minus comes outside. Sine of minus of sine of 1125 degrees. This is nothing but minus of sine of this can be written as 360 times 3 plus 45. So 360 times 3 will actually give us, again, this is the time period is 360, so this will be negative sine of 45, and sine 45 is nothing but 1 over root 2. So this is the answer. Let's move ahead. This one says that we need to find the value of tan of negative 585. So again, tan is an odd function, so minus comes outside. Now 585 we'll try to write as a multiple of its time period, which is 180. So this is nothing but 540 plus 45, and 540 is nothing but 180 times 3. So we have 180 times 3 plus 45, and this is nothing but negative of tan of 45, and tan 45 is nothing but 1. So answer is minus 1. Let's talk about the last one in this particular concept. And this particular concept, so this one says that we have tan of 270. So tan of 270 can be written as tan of 180 plus 90. And since the time period of tan is 180, so this is nothing but tan of 90, and tan 90 is infinity. So the answer for this one is infinity. So these were the examples on odd, even, and the periodic property of the trigonometric functions. Now let's move ahead with the other concept which we discussed, which was the signs of trigonometric ratios. So if we talk about the sign, we have a couple of examples here in which we need to find just the sign of that value and not the final answer. So the first one is sine of 330 degrees. All we have to do is we have to first find out the angle. Pardon. We first have to find out the quadrant in which this angle lies, and then we have to remember the rule. So 330, the best method to visualize that where the angle actually lies is we make a small coordinate plane, uh, and then we try to plot or locate this 330. So we know that we need to start from positive x-axis, and we travel anti-clockwise sense because all the positive angles are in anti-clockwise sense. Uh, we need to remember these angles. So this is 90, this is 180, this is 270, and this is 0, or let's say 360, one complete revolution. So 330 will definitely lie somewhere over here. We are not supposed to find its actual location, but just the quadrant. This is quadrant 1, this is 2, this is 3, and this is 4. Now, since 330 is in quadrant 4, and we know that sine in quadrant 4 is negative, so this is negative. Likewise, we have the second one. This is cos of 745 degrees. Now, we start from here. We make one complete angle, so we come at 360. We complete another angle, so we have 720. So 720 comes over here, and 720 plus 25 will definitely be somewhere here. So this is again quadrant 1, and in quadrant 1 all the trigonometric angles are positive, so this will be positive. Third one is tan of 390. 390 is definitely 360 plus something, so it will also lie somewhere in quadrant 1, again positive. We have cot of 345. So 345 is when we have one complete cycle, we reach at 360, but this is somewhat less than 360 and greater than 270, so it has to be quadrant 4. And in quadrant 4, cot is negative, so we say this is negative. Next one is we have sec of 310. So again, 310 is more than 270 and less than 360, so it has to be in quadrant 4. And in quadrant 4, sec is positive. So we have positive over here. Let's talk about a couple of more examples. So this one is cosec 500. So 500 is we have 360 over here, and 360 plus 90 is 450. So definitely this is slightly more than 450. So it must be in quadrant 2. And in quadrant 2, cosec is positive. So this is a positive number. And then we have sine of 600. So sine of 600 is, again, we just talked about, this is 360, then plus 90 will be 450, and 450 plus 180 would be so we have 450 and 180, so that comes out as 3 is here and then 6 is here. So this one will be 3630 will come over here, this one, because we have added 180. So this is just less than 630, so it must be in quadrant 3, and in quadrant 3 sine is negative, so this value will come out as negative. So this is how we have to find out the signs of all the trigonometric functions. So making a quadrant of such a rough quadrant in our work actually helps us to determine that where these angles will actually lie. And we just have to remember that simple rule that in first quadrant, all the trigonometric angles are positive or ratios are positive. In second one, only sine and cosine are positive. In third one, only tan and cot are positive, while in fourth one, sec and cos are positive and rest all are negative. All right, and the last concept which we discuss in this video would be about the last bit which I talked about in my blog post, that what if we have something of sine of n pi plus minus theta? What if we have something of this kind? So this can either be sine theta or it can be negative sine theta. So definitely this applies for cos, cosec and sec as well. So how to decide whether it's positive or negative? So there is a concept behind that which we'll discuss now. So let's say, for example, we need to find the value of sine of 7 pi over 2. So treat this not as a question but as a concept, that how to approach such questions. So first off, the first step is we try to write this angle in this format. So we should have a multiple of pi plus or minus certain angle. So for that, what I will do is, since we have over 2, so I will try to write 7 pi as 6 pi plus pi. Why I'm doing this is because if I split these two numbers now, that will be 6 pi over 2 plus pi over 2. So this will help us to write this as 3 pi plus pi over 2. So we notice that we have converted this in this form where it's n pi plus theta, where n is 3 pi. All right. Now we don't have to worry whether this angle is acute, obtuse, or right. It can be any angle. The only thing which we have to remember is this part should be in n pi format, which we have achieved. Now, what is the next step? Next step is just like the previous concept where we make a rough coordinate system and then we try to locate this particular angle, right? So we know that this will be pi and this will be 2 pi and this will be 3 pi. Now we have 3 pi plus something. Now don't bother about whether this angle is acute, obtuse, or right. But we have 3 pi plus something. So 3 pi plus something will be in quadrant 3, right? So we have to write this as, and in quadrant 3 we know that sign is actually minus. So along with a negative sign, we have to write sine of theta, because we just discussed that this can either be sine, this can either be positive sign or negative sign. So positive or negative depends upon the quadrant in which that particular angle would lie. And how to find that angle? Using this concept, wherein we try to locate this 3 pi plus theta, and always remember that this should be considered as a theta and not any actual angle. So that will be negative sine of pi over 2, and sine of pi over 2 is nothing but 1. So the final answer in this case is minus 1. Let's write a couple of examples to understand this concept better. So let's say this one says that we need to find the value of cosine of 7 pi over 4. Again, the first step is we need n pi something, uh, n pi plus minus format. So let's try to write 7 as 8 pi minus pi. Now, why I'm doing this is because I know that 8 is actually divisible by 4. So in the next step, I will split these two and I'm going to write this as 8 pi over 4 minus pi over 4. So this comes out as 2 pi minus pi over 4. We have achieved that format. Now again, the same process, we make a coordinate system. We try to locate 2 pi minus theta. So 2 pi minus theta, you notice that in my, while I'm working, I'm always considering this as theta and not pi over 4, because I'm interested right now in the sign and not the value. So 2 pi minus theta, this is 2 pi and minus theta will be quadrant 4, obviously, because I am going till here and then I am coming back, since it is 2 pi minus of something. So 2 pi minus something will be quadrant 4, and we know that in quadrant 4 cosine is positive. So I write this as cos of pi over 4, and cos pi over 4 is nothing but 1 over root 2. So this is the answer. Let's talk about another example. So we have to find a value of sec of 11 pi. Rather, let's talk about cosec. So we have cosec of 11 pi over 6. Again, first of all, we need to convert it in the standard format. So I'm going to write it as 12 pi minus pi over 6, because if I will split this, I will get 12 pi over 6 minus pi over 6, and 12 is a multiple of 6. So we have 2 pi minus pi over 6. So again, we draw a coordinate system. This is the 2 pi, and we come down again because it's 2 pi minus something. It's quadrant 4. In quadrant 4, cosec is negative. So I place a negative sign and I write negative cosec theta, and theta is pi over 6. And cosec pi over 6 is nothing but 2. So the answer is minus 2. So these are some worked out examples which will help you understand this concept, because this is actually widely used whenever the problems tend to be uh, a little bit difficult. So this formula comes in handy, rather this concept comes in handy, wherein we try to find out the sign of that trigonometric function. So I will also complete this table, because cos of n pi plus minus theta will also be cos theta or minus cos theta, and likewise we have cosec n pi plus minus theta is either cosec theta or minus cosec theta, And sec of n pi plus minus theta is also either sec theta or minus sec theta. Always remember that n is an integer, and most important thing is theta is any angle. It can be acute, it can be obtuse, or it can even be right. But the concept over here is we always regard this as, we always keep this in our priority. So if it is 3 pi plus theta, all right, let's work out on another example which will actually clear the point which I'm trying to make. So let's say we have to find a value of sec of 7 pi plus let's say any 4 pi over 3. Yes, what is the value? So this is already in the form of n pi plus theta, although theta, if you notice, it is obtuse. In fact, it is more than 180. So, but we don't care what this value is. We are just interested in this first one, which is 7 pi. So we make this, we travel, this is pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. 7 pi will be here. So at 7 pi, we are at this point P, and we have 7 pi plus theta. Plus theta will be over here, so we are in quadrant 3. In quadrant 3, sec is negative, so we place negative sec of 4 pi over 3. Now, we don't know the value of sec of 4 pi over 3 as well, because we just remember the standard angles which are from 0 to 90 or 0 to pi over 2. So what we do is we again break this in 3 pi plus pi over 3. This can be written as 3 pi over 3 plus pi over 3. This is nothing but negative of sec of pi plus pi over 3. Now again, we do the same procedure. We have pi plus theta. This is pi, this is theta. Again, we have quadrant 3. In quadrant 3, sec is negative. So we have one negative is as it is, another negative sec of pi over 3. Sec of pi over negative and negative is positive, and sec of pi over 3, we know that this value is 2. So the answer comes out as 2. So I hope now it's clear that the point which I'm trying to make is, it doesn't matter whether this angle is positive, negative, this angle is acute, obtuse, or right. All the which matters is the first angle, and we always regard this angle as theta. So that's what we are covering in this video, and if you have any further doubts, any further clarifications, concepts, questions, please post that in the comment section. And you can also send me an email if you are interested in a one-to-one tutoring session as well. So thank you so much, and looking forward to see you again in the next video. Thank you and bye-bye.